Okay, so we're talking about graphing. We got the big graphing number 4 test. It's on sine, cosine, tangent, but not just those. It's also the sister functions. So you got to know all 6 things and how to graph them. Let's just take a second to review the 6 things you have to know how to graph, and then we'll talk about stretching them and flipping them and the right order to do it in. And if you can do all of those things, you're going to be fine. Okay, you got to be able to graph the 6 things and then stretch them different ways, flip them, and move them. All right, so start by just graphing sine for me. And you got to know the 4 major spots. You know what? They're going to be the same exact numbers on every single graph. But you need to know what they are. Make a quick sketch of it right now on your notes. You should do it without me because by now, you should know which one sine is. If you're sine handicapped, it starts at 0 and it goes up. All right, so it goes up and then back down and then back up again. Okay, so now what's this spot? Pi over 2. This spot pi, this spot's 2 pi, and this is always the hardest one to remember. And the way I like to think of it is, and I'm telling you, this will come in handy. If that's 1 pi over 2, that's 2 pi over 2, which reduces to pi. That's 3 pi over 2. Just count it up. 1 pi, 2 pi, 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. And that's 4 pi over 2, which also reduces to 2 pi. Okay, so there's the sine graph. Would you make me a quick sketch of cosine? Very similar. Don't even have to number those 4 spots because they are always the same numbers. Make me a quick sketch of cosine. Alright, cosine's different. It doesn't start at 0, it starts at 1. And then it makes its way down to 0 and then down to -1. And then all the way back up. So it's basically a big valley shape. Raise your hand if you do that. Good. Now, on top of sine, see how we're going to be really efficient here? On top of sine, what can we sketch? Cosecant. Cosecant will be like this. It rides on the humps. If you remind me later, I'll have to play that song for you because I bought it just for that. Alright. And put in a few little dotted lines. Those are called what's? Alright. And there we go. Now, is that 1 period of cosecant or 2? It's 1. So 1 up, 1 down makes a total of 1 cycle or 1 period of cosecant. Notice that it gets over with between 0 and 2 pi. So its period is 2 pi, just like sine's period is 2 pi. All right, and then what would be riding on the back of cosine? And why is it harder to sketch? Well, cosine, if I make like that, there's 1 down. And then am I asymptote lines here and here? The up line has to be like half of 1 here and half of 1 there. Why can't I just complete it and go like this? Because now you just sketched 1 1/4 periods of secant. The green one there is secant. That's my reminder to take attendance. Actually, that was a random spam call. So I better shut the thing off. They're trying to sell you crap. All right. Sorry about the delay there. My phone is set to do an alarm when attendance is due, and that's what I was thinking that was. All right, let's move on. So we've just graphed secant. Except I did it wrong because remember, I threw on that extra part at the end, this extra little piece of the U. If I got this one out of here, then I'd have 1 up and 1 down, and that would be 1 full period of secant. Or I could do it by just, I'll be back in time here, and there we go. That was also 1 full period of secant. Yes, sir. Yes, I like, if you, besides memorizing it, the way I would think of it is secant. You're talking about secant now, right? Well, you really just have to memorize sine and cosine Because if you don't have those memorized, it's going to be really, really tough. But once you've got those two down, knowing that cosine rides on the back of, or secant rides on the back of cosine obviously helps you because you graph the cosine first. If you really want to know more about why it's that way, it's because secant of x is really equal to 1 over cosine. And so then what's really crucial is whenever that's 0. So whenever the blue line touches 0, that's where the asymptote line's going. And then the rest of it is always wherever this one is rising, this one would be falling because they are inverses of each other, because basically it's 1 over that function. All right, let's move on to tangent and cotangent. Everybody sketch tangent. And I'm going to help you because there's an easy way to do this and a hard way. The easy way is just to memorize the tangent. Goes between the first mark on either side of the x-axis or on the y, with the origin. And it just generally goes up like this. It's always rising. That's tangent. Now there's a complicated way to try to figure it out, and that is the tangent is sine over cosine. Tangent is sine over cosine. And I showed you that when I first introduced the graph. The key spot is where cosine is 0. Wherever cosine is 0, you have these asymptotes. These asymptote lines here are happening because cosine would have been 0 at this point. But just another way to do it is this. Every mark that we do starts out as pi over 2. Now sometimes we stretch them and stuff, but they always start that way. So this one goes between pi over 2 and negative pi over 2. All of our graphs are that way. We can always count by those little marks. And why is that? Because think about it. If you're on a circle and you go this far, that's pi over 2. You go another notch, that's another pi over 2. You go another notch, that's another pi over 2. And you go another notch, and that's another pi over 2, a total of 2 pi. It all makes sense if you think about it from this perspective of a circle being divided up into 4 parts like that. That's why we have 4 major marks that we use. Okay, so there's tangent. So now, is the test that simple? No. A question like graph sine of x wouldn't even be at R2. There is no such thing. That's so easy. But they would ask you how to do some little shift or stretch or whatever. So let's try this. Why don't you make 3 sine of 2x? Start by just graphing sine. 4 marks. It's your home position, your safety. Should have that kind of memorized. Should be easy. And then just change the numbering. All you got to do is change the numbering, and you'll have it. I'm going to pause for a second while you do that again. All right, here's what you should have done. You should have started with sine, normal. Just like that. Then, normal is 1, but we don't make it normal. 3 there, and a negative 3 down here. Raise your hand if you caught that part. Good. Next part is the 2. The 2 is using this formula. Period is 2 pi over whatever. And the whatever, b term, is right there. 2 pi over 2. Then when the 2's cancel, you have pi. My new period is pi. So this used to be 2 pi all the way back. I'll just number them quick here. 3 pi over 2. And now I'm going to change. Crossing this off. It's no longer 2 pi. It's now pi. And what did I really do to it? Divided by 2, or another way to say that, multiply by a half. So everything needed to be multiplied by a half here. And this would come out to 3 pi over 4. This would come out to pi over 2. And this would come out to pi over 4. And then if you want to check yourself, because I'm telling you, this is where most people are going to get marked wrong on the test. They won't make, who's going to draw the sine curve wrong? I mean, they're all going to make a curve. Okay, that's easy. It's the numbering down here. So if you want to check that, here's how you check it. You ask yourself, okay, what's that? Don't say pi over 4. Say 1 pi over 4. And then what's this? 2 pi over 4. Does that reduce to pi over 2? Yes, it does. 3 pi over 4 and 4 pi over 4. See if I count them up that way? 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. That'll help make sure you numbered them right. All right. Just the ones where you have actually have a graph on it. So like, I got what you're saying. Yes, you have to have all 4 marks labeled. Any place, put it this way. I'll try to say it to you differently. Wherever the graph is, wherever I just, like, in that whole area, all those marks need to be labeled all the way through there. Okay, technically I should put a 0 here, but I'm not going to mark it. Not having a 0 at 0, 0, because it's pretty obvious. Okay, so the reason I bring that up is because what if I just shifted this thing to the right one? A lot of kids are going to screw this up. Shift it over one mark, which is pi over 2. How would I shift it pi over 2 to the right? I would have a minus pi over 2 right in here, like that, you know? Anyway, if I did that, see how it is going over here and there's no label there? You'd have to label that spot. So that's, like, how do I get that spot over there? What's 1 past 2 pi? The way I was suggesting it was counted up. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi. About 5/4. So if I moved the thing over, I'd have to know what that mark was. You know what I'm saying? Because I counted it up using my new numbers here. All right. So where do you have to label it? Wherever the graph is. So, like, a lot of times the test itself is going to have a whole bunch of marks. You won't have to use all of them. If you just use the first 4 marks, label those first 4 marks. All right, moving on. Let's get into a different kind of problem, just kind of shake things up a little bit. You can also just be required to know what are the things you have to do and in what order. These can be particularly hard because there's a lot of things you can do. This is like the most challenging of all of them. -5 cosine of -1/4 x minus pi over 2 plus 7. You could be asked all of those. Okay, 10 minutes. So, how many things are there? 1 thing, 2 things, 3 things, 4 things, 5 things, 6 things, and in the right order. All right? I'm going to tell you real quick the order of this one, just super fast. Generally, you start on the inside. Once you're on the inside, you do things in the opposite of normal order. To understand normal of stretching and shrinking, or stretching and flipping, think about it this way. In gymnastics, what should you do first, stretch or flip? You should stretch first. Then you're going to pull a muscle otherwise, right? So stretch first, normally. But we're on the inside. And so if you're on the inside, the stretching and flipping you have to do in the opposite of normal order. Now, I'm just going to give you a way to do this. Granted, there are like 6 different ways you can do it, but that doesn't mean you could do it in any order you want. That's really important. Kids sometimes think, well, you can do it forwards or backwards, and so it doesn't really matter. Totally matters. A lot of kids get it wrong for the order you start. So, of these things, which should be first? Well, it's got to be something on the inside. Normally multiplies come before subtracts. So, since we're on the inside, we should subtract first. That can be first. So your step 1 would be this. Then, of the other 2 things that I have to pick from, stretch before you flip is normal. So I'm going to flip before I stretch. So this would be number 2. This would be number 3 then. It's the only thing left on the inside. Then you go to the outside. And of these things, the add or the multiply, which one normally comes first, multiply or add? Multiply normally comes first. And therefore, it does go first. And of these 2, the 5 or the negative, stretch before you flip. Remember that? So I should stretch first. So this should be next. This would be my 4th one. Then this would be my 5th one. And the last thing would be this one. All right, that was as hard as they would get. Yes, sir. No, you do the exact opposite on the inside. Yes, wait. Go back to here. Yes, actually, you can. But I've tried to give my kids a way to know which of those 2 should go first. So it is often true that on a graph, it's actually practically easier for you to do the stretch first before the flip. Because if you flip it, then all your numbers are reversed. Or the opposite, and then it might be harder for you to do the stretch. So bottom line is, I agree with you that between these 2, you really don't have to stretch before you flip. But when you're actually doing it, stretching first makes some sense. Yes. Yes. But the problem is, What I don't want you to do is think, oh, so anything goes. You can pretty much do anything. No. There's actually probably 25 ways this could be done. And there'd only be 2 of them that would be right. Actually, no, there'd be more than that because of the fact that these 2 can be reversed. But let's say there's 4 of them that are right out of 25 possible ways. So I just don't want you to think. See, what I'm afraid of is if I tell you just, oh yeah, I can go outside, inside, or inside to outside, and you can do these first or that first, then it's so many things that are variables that you get really confused. So I give kids one way to do it. And if you start on the inside, that's the way almost all major math problems go. Whenever you have something complicated, you start on the inside of it. You have nested parentheses, start on the inside of it. When you start on the inside, and the other thing I strongly recommend is remembering that on the inside, everything's opposite of normal order. All right, now let's try one where you answer this and see if you get it right. Yes? No, you wouldn't actually have to graph this one. It'd be way too complicated. You just say, first would be flip it. Second would be blah, blah, blah. Okay, so let's do that right now. Let's try one. And I think really what you're getting at is if I do it in a right order, are you going to mark it wrong? No. If you have written down a correct order, even if it's backwards from, like if you learned it in a different class where you could go outside to inside, yes, I'll accept that as long as you follow the rules that are critical. Like on the inside, it has to go in the opposite of normal order. Period. And if you switch around a flip and a stretch, will I mark it wrong? Nope. Because technically it's the same thing. But if you follow the rules that I've showed you, I think giving you one way to do it is way easier than trying to teach you, here's the 6 different ways you could do this. Because then it gets more confusing. So just on this one, start on the inside. And let's try these things. Just write down 1, 2, 3, 4. What should be the 4 things you should do? Like, for instance, let's say you thought it was going to be start with, no, I'm not done yet. There's 4 things there. Notice that 5 is not in the things. Okay, so if you thought you were going to start with getting 4 times taller, you'd write 4 times taller. That would not be the correct answer. If you're going to start on the inside, you should obviously start with that 3. Tons of kids mess up that 3. What do you think the common mistake answer is on the 3? 3 times what? 3 times wider. And it's not. What is it? It's narrower. If you say shrink factor 3, or if you just got to get across the point, it's getting smaller. The way I'd say that is 1/3 as wide. Otherwise, you could say horizontal shrink. If you get across the point, narrower is another word that gets across the point. Yep. All right. Next thing. Once you're done with the inside, you go to the outside. All the outside stuff, what should be first? Well, normally, multiply stuff goes first. Do you do it in the normal order on the outside? Yes, you do. And of those 2, I just give kids a way that usually works better in real life, which is stretch before you flip. Technically, you could reverse. Stretching would be 4 times taller, otherwise known as a vertical stretch factor 4 would be a great answer mathematically. And the next one is that negative, which would be a stretch, no, a flip. Up, down, flip.